The second most asked question on my channel is, what was this piece of gear used originally for? Sometimes there are manuals or catalogs, but oftentimes it's simply lost. Luckily, for what is arguably the first commercially available sampler, the Brüel & Kjær event recorder, the original designer chimed in the comments. So I reached out to him for an interview. If you've no idea what I'm talking about, stop this video right now and go to the description. There I put links to 2 videos I made on the Brüel & Kjær 7502 and then come back to watch the rest. I find it a fascinating story.
I started working for Brüel & Kjær in '67, right after my degree at university. The first couple of years I worked with analog filters. In '69, Brüel & Kjær started a digital group of which I became a member. One of the founders, Dr. Brüel, brought my attention that he was a member of a working group which were looking for instrumentation to capture your sonic boom from your Concorde.
Oh, wow.
It so happened that I had a friend working for Intel in Denmark. Mm-hmm. And he informed me that Intel had brought to the market a 1K shift register. I saw it once that it could be what was needed to make a total electronic replacement for a tape loop.
Yeah, because that was the technology at the time to record. It was tape loops.
Yes.
Brüel & Kjær had a whole series of tape recorders for measurement, right?
Yeah. The tape loop wasn't suitable for this application because it had to run continuously 24/7, and it wasn't at all reliable enough.
Mm-hmm. And because you needed to record the sonic boom, was that because of loudness considerations?
Yeah, it was actually under consideration that the Concorde would be fined if your bang was too loud. Almost when we had finished the development, it was decided by authorities that it would be too costly and too cumbersome to enforce this regulation. So it was instead decided the Concorde must only fly above the sound barrier overseas.
Once it hits the Atlantic, it goes into supersonic mode.
Yes.
Okay. But that was the first purpose of this instrument, to record that.
Yeah. That was driving force at the start. But we, during development and especially later on, we found a number of applications. So it was decided to put it on the market despite this setback with the Concorde.
Okay. You mentioned in your post, a bunch of applications. What were those?
In shock waves of different kinds. The measurement of hand tools.
Okay.
To see if they met certain regulations.
If you have like a hand drill and that transmits too much vibration, it gets dangerous for the body.
Yes. And it can actually introduce a syndrome called Raynaud's syndrome. I have actually experienced myself when I used an old lawnmower. Mm-hmm. And so after maybe half an hour to an hour, my hands went totally numb. Was a regulation telling how much was allowed to introduce in the hand of your user.
Mm-hmm. And that, of course, you could use a vibration pickup, and then you could record it on the 7502, and then you can make an analysis how far the vibration is and such, exactly. How strong. Yeah. That's like if we were on a Zoom, you could see behind me I've got 2 Brüel & Kjær right now on that are the type 2121 and 2120 frequency analyzers. And I've got the vibration pickups, and I've got the preamplifiers for those. and I'm using those for sound design. I kind of get how the process of picking up the vibration and measuring works. It must have been really challenging to develop something digital that early.
Intel was a tiny, tiny company at that point. Just 20, 30 people.
Really?
But yeah, and these shift registers were enormously expensive. So we actually became a prime customer for Intel, at least for a very short time, because Intel grew with a tremendous speed, and computer companies were purchasing 4 and 8-digit microcomputers.
So when I look inside the unit, there seem to be a lot of chips, like a lot of them. So you needed a bunch of those shift registers to create the...
Your minimum configuration is 2 boards, each at 1K bytes. And then there is room for 4 more boards, each containing 2K bytes. So it's a total of 10,000 bytes in the full configuration. It was introduced in an acoustic conference in Budapest in the autumn of 1971. That was just a preview, because this conference was at that time just every 4 years. So management thought that it would be nice to show to the acoustic community what we were doing. So it was one of a number of brand new instruments. It made quite an interest among the acousticians. I remember very distinctly a professor from MIT in the US, and he worked on speech recognition. And so I think he was actually the first customer we had, and he showed it to a number of people in this field in the States. So we sold quite a number for an application which we hadn't considered at all.
So that's another application. Speech analysis, was that right?
Yes. Yeah.
Yeah. And then, of course, you suddenly see someone making music with it. I'm guessing that was not something you considered. No, it wasn't. Yeah. I must admit, it wasn't at all. Was that strange for you to see someone make music with your design?
Yeah, it was quite a surprise. That's why I found it such a nice experience to see your video yesterday.
That's great to hear, because I mean, Brilliant Care equipment has been a part of the electronic music basically since the beginning, because you found at least the 1022, the Wobulator, I think they called it at the BBC, the filter banks. You found those all over in experimental radio studios, and I always wondered how aware Brilliant Care and the people at Brilliant Care were that their measurement tools were being misused by composers ever since basically the 50s.
I know among my colleagues there were some amateur musicians, and they might have known, but there was no one from my group except for listening.
I mean, it must have also been like prohibitively expensive, like the 7502.
7,000 euros.
Okay.
And this was 55 years ago, so it was quite some money.
Okay, so probably like
the euro didn't exist at that time.
Yeah, that might have been like the price of a Mercedes-Benz at the time or something like that. Yeah, at least. But it's funny, like you created something, like when you use it wrongly, I mean, like when you not use it not as it's intended, that could be classified as the first commercially available sampler, which is a crucial music tool for musicians since the 80s, basically.
To demonstrate their frequency capabilities of your 7502, it was quite interesting to have a small bell, pick it up by a microphone, capture it in your 7502, and then by change the output sampling frequency, say to maybe 10 times lower speed than your sampling speed. Then you and having a loudspeaker on your output, you could actually think it was a bell 10 times bigger.
So
it was very illustrative.
Exactly, yeah. So you did get the kind of acoustic experiments, and you played them back like that also, that I basically also did. Oh. Filter on? Oh.
We chose to use 8-bit only because it would be very expensive to go to 12-bit, which would be your next logical choice.
You could, but at that time already, you could have gone to 12-bit.
Oh yeah, easily. But we found that it would be too expensive.
Okay. Yeah, 12-bit that came around like in commercial musical instruments like way later. So probably when it was more cheap to do it. So, but there must have been a rapid time of development, because you mentioned you worked first with analog instruments and you worked with analog filters, and you and then digital came about. That must have been a very exciting time.
Oh yeah, it was, and in principle, it's a very simple instrument. So, and it was my first development by myself. So it was also a good teaching tool for me. But quite simple to develop, really. I mean, compared to the frequency analyzer we did later. That was complex.
Do you think there's other measurement devices that are still waiting to be discovered for their musical purpose?
Well, I really don't know.
Okay.
See, right after I had finished development, I went on a tour to some European countries to help introduce it. But I more or less left the project by end of 72 to participate in development of the first Concorde digital 12-octave analyzer. It came on the market in 76, and I'm very sure that this is the first analyzer with digital filters.
But this doesn't have an audio out, no?
No.
Yeah, there's no way to listen to it. That's always what I'm looking for. I'm looking for like if there's an audio out, it might have a chance to listen to it. After Blinkier, Mr. Madsen had a very successful career. He developed instruments that are used still on the space station.
It was flown to the space station in 2003, and it's actually still in use at the space station.
And in the oil and gas industries. Since this is out of the scope of my channel, which is all about making music, I put a longer unedited version of that interview on my Patreon, where you can watch it in full. If you have any more questions, put them in the comments below, or visit the Heinbach subreddit, which is a very good place for tape and test equipment music. Thank you all for watching. I'll be seeing you in the next one. Bye.